The eighth redesign heuristic is communication optimization. This redesign heuristic tells us we should consider automating the handling, meaning, for example, the receipt and the sending of messages, their recording, and their organization. In a similar vein, we should automate our message exchanges with customers, and we should record exceptions in order to learn from them on a continuous basis. But perhaps more importantly, what this redesign heuristic tells us is that we should try to optimize three things: the number of interactions with the customers and with the business partners with which we have to interact in a business process, the type of interactions, and the timing of these interactions, in particular trading off synchronous interactions with asynchronous interactions. Let's look at each of them. Optimizing the number of interactions can be achieved by designing every interaction we have, every message exchange we have with either a customer or a business partner in a given business process to gather exactly sufficient information from that stakeholder that we need in order to reach a certain logical milestone in our process. That means we have to define where is it that a given interaction needs to lead us. What is the processing that should follow and what milestone that processing should allow us to achieve. Optimizing the type of interaction means that we have to consider the relative benefits and disadvantages of synchronous versus asynchronous interactions. By synchronous interactions, we mean that we interact in a request-response mode. Like, for example, we contact the customer and the customer answers our questions exactly at that time. That could be, for example, via a phone conversation. Asynchronous means that we decouple, sending a message from receiving a response. For example, we will send an email to the customer and we will wait for a potential response later, or perhaps no response is required. Synchronous interactions, in general, are very effective to resolve minor defects or to obtain very well-defined, very well-scoped pieces of information. Asynchronous interactions, on the other hand, should be considered when we have to simply notify or inform the customer, for example, about the status of the process, or when we need to resolve major defects that cannot be resolved in the time of the interaction itself, or when we need to request additional information in order to reach the next logical milestone in the process. Perhaps equally important or more important is to optimize the timing of the interactions. In this respect, we have to be careful about not backloading the process. A backloaded process is one where the bulk of information exchange and information processing is left to the end of the process. An example of this can be found in the context of a large pharmacy chain in the US, CVS Pharmacy. In the early 2000s, CVS Pharmacy had introduced a system of drop-off and pickup of prescriptions that allowed customers to arrive in the morning, drop their prescription, and nominate the time when they would like to pick up the prescription. When a prescription was received, it was put on a box. 1 hour before the scheduled arrival time of the customer, meaning 1 hour before the customer returned to pick up their drugs, the prescription was taken from the box by a pharmacist. A number of steps were taken to enter that prescription, to do a number of checks whether, for example, the prescription will be paid by the insurance company of the customer or not, and how much, to determine if it was actually safe to serve that medicine to the customer given the previous history of prescriptions that the customer have had. Also, to determine whether actually the medicine was in stock or not, and to actually pick it from the shelves and serve it. A major issue with this process at the time was that very often issues were detected at the very last minute, just before the customer arrived. When the customer arrived, the issues were communicated to the customer, and only then the resolution started. The problem was in part that customers arrived to pick up more or less at the same time when they came up from work, meaning that during peak time we will be trying to resolve synchronous interactions in a queuing system, all the issues that we had found during the day. And obviously this led to frustration from the customers because they were expecting, given that they dropped off their prescription in the morning, they were expecting that they would have a smooth pickup in the afternoon. This process had the problem that it was backloaded. There were too many problems, too much information processing and too much information exchange left to the end, and it needed to be a little bit more balanced, meaning some of the information exchange and processing tasks needed to happen more upfront in the process. We could have this same process completely front-loaded, which means we try to resolve all the problems and gather all the data when the customer drops off, and then only leave minor tasks for later. In that particular case, this would not have been a solution to the problem, because it so happens that customers were dropping off when they were in a hurry to get to their work, and they didn't have the time to queue behind other customers who were trying to get their questions and their issues resolved. So what this process needed is a nice balance between having too much front-loaded communication or too much back-loaded communication.